In this video, we are going to look specifically at how to solve what are called compound inequalities. Compound inequalities are inequalities that end up with two symbols. You can either be shading towards each other or you can be shading away from each other. Because of that, we have two types of compound inequalities. The first type is called a conjunction. Conjunction uses the word and it means that you're going to shade towards the center or towards each other. For example, you may see problems like this one. Let's say -5 is less than x plus 2 and x plus 2 is less than 15. Or you can see it commonly written as a single inequality, where you have your center point or your variable here in the center, and then you have your outer variables or your values on the outside. And notice both of my inequality signs are pointing in the same direction. All of those are characteristics of the word and. The other type that we have is called a disjunction. Disjunction uses the word or and has inequality symbols that face the opposite directions. For your disjunctions, you'll be shading towards what are called your infinities. If you look at this example here, you'll see that it kind of looks like the wings of a bird or the oars of a boat. Okay, you're shading out to the outside, you're kind of leaving an empty spot here in the center, so this would be or. In this example, notice we have 3x is less than -6, or 3x is greater than 2. A couple things to note. First, the word or. Second, both of your inequalities are facing in opposite directions. Those are the two characteristics that will constitute a disjunction. Now there's a few things that you need to watch out for. Okay, and specifically when dealing with disjunctions, you need to pay attention to the wording. For example, if it says or, then you need to look at where you need to shade, okay, on the actual number line itself. If it says and, then you're looking for the shadings to overlap with each other only. Okay? So in terms of when we're trying to figure out where to shade, the word is very important. And means we're looking for the places where the two values coincide with each other. And or means we're just simply looking at everywhere you need to shade to that specific inequality. So what we're going to do is we're going to look at 4 different examples here, all of which are going to be shading in different ways, and we're going to look at the differences between a conjunction and a disjunction, especially in the makeup of the problem. So let's take a look at our first one here. So we need to solve the inequality, write the solution using interval notation, and graph it on a number line, just like any other inequality problem. Okay? So here, the first one, we need to decide what it is. Remember, we only have 2 options. So the first thing we look at is how is it set up? Well, notice I have it set up as just one straight inequality. I've got my variable here in the center, and both of my inequality signs are pointed in the same direction. It would be very clear to me that this is going to be an and problem. And if I want to give myself a reminder, I can remember that and problems shade to the middle. Okay, that's what we're looking at. So I need to get this x totally by itself. So whatever I do to the middle, I have to do to the outer sides, both outer sides. So the first thing I'm going to do is I'm going to take this 1 and I need to move it. Well, I have to move it this direction and the other direction. It is being added, so to move it says that I'm going to subtract in both directions. So here I'm going to have -3 minus 1 is going to give me a -4. I did not add or multiply or divide, so my sign stays the same. I've got a 5x left in the middle. Again, my sign stays the same. And 3 minus 1 is 2. Now the last thing I need to do is I need to divide all three of these by that 5 to get x totally by itself. So here this is going to be -4 divided by 5. My 5 was positive, so my sign stays the same. X is in the middle. Again, my sign stays the same, and I get 2 over 5. Now the last thing you want to do, because I have fractions, is you always want to look and see, can I reduce any? Well, in this case, no. So here, I'm going to go ahead and graph it. So I'm going to draw out my number line here. I've got negative infinity to positive. I'm going to slap my 0 here in the center. I'm dealing with -4/5, and I'm dealing with 2/5. So now I need to go ahead and fill it in. Well, my inequalities are just straight good old inequalities. So this is going to be a parenthesis. It's an and, so I'm going to be putting my parenthesis pointing towards each other. So we're going to put that in on either side. So there we go, a good parenthesis on either side. And we're going to shade right here in the middle, which is where the two overlap. Now you want to make your interval match your graph, so we're going to open a parenthesis, -4/5 to 2/5, and close that parenthesis. And there you have it, there's your first one. Alright, let's go ahead and take a look at the second one. So here, notice I have 1/3, 7/6, and 2/3. Here I have an LCD of 6. So the first thing that I'm actually going to do is I am going to multiply my entire equation here by that 6. 6 over 3 is going to become a 2. So this is going to be 2. My 6 is positive, so my sign stays the same. 6 over 6 goes away. So this is now 7 times 3 minus y. Again, my sign stays the same. And here, again, 6 over 3 is 2, so this is 2 times 2. Let's go ahead and keep simplifying. So here I've got this 2, sign stays the same. And in this case, to make life easy so that I'm not working with fractions, I'm going to go ahead and distribute through. Because I know on the other end I'll be dividing it back out, but at least this way I can work with whole numbers. So here this is 21. Minus a 7y, my sign stays the same, and this is 4. I gotta take my 21, so this here, and I'm gonna move it in both directions. So here I've got 2 minus 21 is going to give me a -19. Keep my sign the same, I've got a -7y. And here I've got -17. I need to divide this whole thing by a -7. So when I do that, I want to take a look. Notice right here that I am going to divide by a negative. Remember, when we do that, we need to flip your signs. So in this case, this is going to be -19 over a -7. I got to flip my sign, so now it becomes the other direction. Y is in the middle. Flip my sign again. -17 over -7. Last, take care of my negatives. So this is going to be 19 over 7 is greater than y, greater than or equal to 17 over 7. So last but not least, I need to go ahead and graph it. So I'm going to draw my number line. I'm going to have my negative infinity and my positive infinity. I'm going to go ahead and I'm going to slap my 0 in here. And then I've got 17 over 7 and 19 over 7. Now notice I'm giving myself a little space so that I can see how it works. And notice that my inequalities. 17 over 7 has an equals, 19 over 7 does not. So here this is going to say 17 over 7 is going to have a bracket. 19 over 7 does not. It's a parenthesis. And then we're shading in the middle. Now, last but not least, we need to write our inequality. So we're going to start with a bracket at 17 over 7, travel up to 19 over 7, close it with a parenthesis. Okay. Now this next one, I want you to take note that we have the OR. So here this one says that if we're looking at our number line, remember we are going to go in opposite directions. Okay, that's kind of what we're doing. So we have to solve both of these problems, but we have to solve them by themselves. So here I've got 3x minus 1 that I need to get by itself. So I'm going to move the 1. So this becomes 3x is less than negative 4. Divide everything by 3. X is less than negative 4/3. I'm going to slap in my r here so that I don't forget it, and I need to work the other one. So here this is going to become 3x is greater than 6. So x is greater than 2. I need to graph each of these individually. So I'm going to go ahead and start my number line. I have negative infinity and positive infinity. I'm going to put my 0 kind of right here in the middle. Let's start with the left hand side. I've got negative 4/3. And I want x to be less than that. Notice there's no equals, so it's going to be a parenthesis. So my parenthesis is going to open facing the negative side. And then I'm going to shade down to the negative piece. On the other side, I've got a 2. My x is greater than 2. So my parenthesis is going to open towards the positive infinity, and I'm going to shade down on this side. Notice it looks like wings, so I know I've shaded it the right direction. So the last thing I need to do is write my inequality. So we're going to start on the left hand side, and we're going to figure it out to the right hand side. You always go from negative to positive. So we're going to start with negative infinity. We're going to travel up to that negative 4/3 and close it. We need to represent this space in the middle, so we do that with a U. It's called a union. Now we're going to pick up where we left off. So we're going to pick up at 2, and we're going to continue on to positive infinity. Alright, the last one, we've got an and here. So we can do this a couple ways. We can solve them as two separate problems, or we simply rewrite it into a combination problem following your inequality signs. So here we could start with the negative 5. Put in your sign. We have 3x minus 1. Notice it's the same. This is 3x minus 1 over here, but now I'm less than 5. So less than 5. So what I've done is I've combined them into my conjunction, and now I can go ahead and solve. So I'm solving my two problems together using one single equation. So here I'm going to take this 1 and I'm going to move it to both sides. So here I'm adding. So this is going to end up being negative 4 is less than the 3x is less than 6. Divide everything by 3. Negative 4/3 is less than x is less than 2. And so here, now we're going to go ahead and graph this one. So we're going to draw out our number line. I've got negative infinity to positive infinity. Put my 0 here. I'm going to start at my negative 4/3, and I'm going up to 2. And in this case, I'm the and. So here I'm going to make my parentheses face each other, and I'm going to shade in the center. My interval is going to match my graph. So I'm starting at negative 4/3, and I'm traveling up to 2 and closing it. So what you need to see out of this is notice these are the same equations. It's just this top example in red was done using a disjunction, and this bottom example here was done using a conjunction. So you can see how the same problem changes ever so slightly based on the word in the middle. So you need to pay very close attention to the setup of your inequalities so that you know exactly what your overall result should look like. Alright, so there you have it. Everything you need to know to get started with working with compound inequalities. If you have any questions, please let me know. If you have any additional examples or problems that you would like to see done, let me know that too. I'd be happy to work them out. Otherwise, I hope you enjoyed, and I'll see you next time.